Let's have problem number 3. Suppose that data on a random sample of used vans of the same brand and model on mileage in kilometers and selling price in pesos were collected and tabulated. Do the correlation and regression analysis. In our table, the X column is for the mileage, how far a vehicle had already traveled, and Y is for the selling price in thousands. First is, we'll be solving for the correlation coefficient. You could use you could do it manually, or you could also solve it using the Microsoft Excel. You can pause this video if you need more time in solving for the table. In this table, I've completed all the entries and the summation are written in red boldface. You can pause this and solve for the correlation coefficient. Based on our computation, by the way, I use Microsoft Excel for this one, our correlation coefficient is negative 0.99. If we check on the interpretation table, that is very high and negative. So it means that it's negative if the mileage increases and the selling price decreases. It means that the farther the van has traveled, the lower the selling price will be. Now let's test for the significance of R. We only have 9 vans, 9 entries, and our R is negative 0.99. We state the hypothesis. There is no significant relationship between mileage and selling price. The alternative hypothesis states that there is a significant relationship between mileage and selling price. In step 2, we'll be computing for the value of t. You can pause this video and have more time in computing for our t. Based on the computation, the value of our t is negative 18.57. We compare this with our critical value. Since our n is 9, our degree of freedom will be n minus 2. That's 9 minus 2 equals 7. Using the t-table for two-tailed, our t is 2.367. By the way, even in the previous slides, that should be plus and minus, since it is for two-tailed. And if we sketched our normal curve, our computed t negative 18.57 is found in the rejection region. Thus, we state a decision, we reject the null hypothesis. Then we state our alternative. Thus, there is a significant relationship between mileage and selling price. Since there is a significant relationship, then we need to do the regression analysis. Let's we have a sample problem. We ask, if the mileage is 80,000 kilometers, what is its expected selling price? Before we can do regression analysis, we need to solve for the values of our A, the y-intercept, and B, our slope. You can pause this video and solve for the value of A. Based on the computation, the value of our A is 718.84. Now let's solve for the value of B. You could pause this video and try solving for the value of B. Based on the computation, the value of our B is negative 4.24. We substitute A and B to our regression line equation. That's y prime equals bx plus A. That will be y prime equals, what's our B again? Negative 4.24x plus 718.84. Now let's do the prediction. We say if the mileage is 80,000 kilometers, what is its expected selling price? Remember that we go back to our table. Our mileage is in thousands. So if the question is on 80,000 kilometers, we just key in 80 and not 80,000. So we substitute 80 to the value of x. We solve it. The answer is 379.69, or that is approximately 380. If you go back to the selling price is also in thousands. So the selling price of the van, whose mileage is 80,000 kilometers, is 380,000 pesos. This ends our chapter review.